Now two important numericals on ray optics. So that a plane mirror of length L by 2, this is a plane mirror AB of length L by 2, is long enough for a man of height L. HF is the height of a man, H is the head, F is the feet. From H to F is L, to view his entire reflected image. Is there any restrictions on the position of the top edge of the mirror? Means how you have to keep the mirror so that he is able to see his entire image. Now AB is the plane mirror, H is the head of the man, F is the feet, E the position of his eye. Now a ray traveling from here hitting the mirror here is reflected in this way towards the eye. This is the normal to the mirror at this point. Similarly, traveling from the feet reaching here at the bottom of the mirror is reflected towards the eye. So let this angle beta, angle of incidence, so this angle of reflection is also beta. Similarly here, let this is the angle of incidence, therefore this is the angle of reflection. Now according to laws of reflection, this HC will be equal to CE because these two angles are equal. This is 90-90. So this is equal to this. Similarly, from the laws of reflection, from here your ED is equal to DF. ED is equal to DF or DE is equal to DF. Now this is perpendicular to this. This is also perpendicular to this. So the length of AB is same as length of CD. So AB is equal to CD. Now your CD is equal to CE plus DE plus DE. Now your CE is half of HE, and your ED or DE is half of EF. So I take half common, so I am left with this plus this, and HE plus EF. HE plus EF is equal to HF. That is nothing but the height of the man. Now if HF is equal to L as it is given, height of the man, therefore AB is equal to half L. Now look here, the top portion of the mirror, the edge A of the mirror is at a level half the height of the half the distance between the head and the eye. Means the mirror should be fixed in such a way that the top end of it lies at a level in exactly halfway between H and E. So that was the first numerical. Now the second important numerical. An object approaches a convex mirror. This is a convex mirror. An object is approaching convex mirror of focal length 25 centimeter with a speed 10 meter per second. This is approaching the mirror at 10 meter per second. What will be the velocity of the image when the object is 25 centimeter from the mirror? The object is moving. When the object is 25 centimeter from the mirror, at that situation, what will be the velocity of the image? What will be the velocity of the image? Now look, light is traveling this way. So all distances we know are measured from the pole P. So distance measured to this side is positive, distance measured to this side is negative. The object is on this side. When it is at 25 centimeter, means from here to this side 25 centimeter, therefore negative. So U is equal to minus 25. And focal length, we have seen in previous lectures, is measured from here to this way. That is positive. It is given as 25. So using the mirror equation, 1 by u plus 1 by v is equal to 1 by f. Put these two values here. I get v is equal to 12.5. That is, the image distance is 12.5. Means when the object is at 25 centimeter from the mirror, the image distance is positive, therefore to this side. So it is at 12.5 centimeter from this point to this side. Okay, now we have found the image distance. We know 1 by u plus 1 by v is 1 by f, where f is the focal length, that is a constant. Let us differentiate this equation with respect to time. So 1 by u write as u to the power minus 1, this as v to the power minus 1, 1 by f is a constant. Now differentiate both sides with respect to time. So differentiating this with respect to du into du by dt, that is same thing as du to the power minus 1 by dt. Then this one, dv to the power minus 1 by dv into dv by dt, that is same thing as dv to the power minus 1 by dt. Derivative of a constant is 0. Now the minus 1 comes here, its power reduces by 1, becomes minus 2. So I am left with du by dt. This I just showed you how to differentiate. Then here, from here minus 1 comes here, then power reduces by 2, then dv by dt is equal to 0. Now, so this becomes, now I multiply throughout by minus 1. If I multiply this with minus 1, becomes positive, this with minus 1 becomes positive, I multiply this with minus 1, it becomes 0. So I am left with this is 1 by u square du by dt plus 1 by v square dv by dt is 0. I take this term to the right hand side, becomes negative. Now becomes negative. Now I take v square to this, v square here comes here, so v square by u square, that I can write as v by whole square of v minus u. I bring the negative sign also here, du by dt remains here. So on the right hand side I have left with dv by dt. Now what is dv by dt? Don't confuse, v is not velocity here, v is the image distance. U is not velocity here, u is the object distance. So how the image distance v is changing with respect to time is image velocity. How the object distance u is changing with respect to time is equal to object velocity. So dv by dt is equal to minus, when now the image distance is 12.5, when the object distance is equal to minus 25, put it here, and when the velocity of the object is given 10 meter per second, so I put it here, I get it as minus 2.5 meter per second. The negative sign implies the image is moving towards left. The image is moving towards left, because from this side to this side is positive, from here to here is negative, so it is moving towards left.